Okay, we're going to do question number 9. Jack texts Jill that they should meet as soon as possible. Jack leaves his house and starts to run at 6 meters per second towards Jill's house. That is 8.58 kilometers away. Jill first puts on her running shoes and then 3 minutes later starts to run towards Jack's house. So she takes a 3-minute break to put on her running shoes while Jack is running. But she runs at 9. How long in time does it take for them to run till they meet somewhere in the middle? And then, whose house are they closer to? So Jack and Jill are 8,580 meters apart. But Jack does the head start, okay? Because Jack starts running right away. So there's the head start portion. And it's just him running. So the velocity of Jack is 6 meters per second. How much of a head start does he get? A 3-minute head start, which is 180 seconds. So how much of a distance does he get in a head start? The distance is velocity times time, and velocity is 6 meters per second. The time is 180 seconds. So when we multiply those together, we get 6 times 180, and that is 1,080 meters. So that's the head start portion. That's how far Jack runs by himself. Now we're going to start the relative velocity. Now, why is it relative velocity? Because both are running. So VREL, the relative velocity, write down both of their speeds, 6 and 9. Do we add them or subtract them? Since they're towards each other, we add. Because if they're towards each other, they're in opposite directions. We add them. And if they're the same direction, we subtract. So that's the rule for, since they're in opposite directions, which is heading towards each other as opposite directions, this speed is 15 meters per second. The distance relative is how much distance they have to run together. Jack has cut some of that off. He has taken this 8,580 meters and reduced it by 1,080 meters. He's already run just over a kilometer before she starts to run. And that makes that they're only now 7,500 meters, 7.5 kilometers apart. That's the relative velocity section. So we pull up our formula for that. And T is equal to DREL over VREL. And that is going to be 7,500 meters all over 15 meters per second. $7,500 divided by 15, 500 seconds. Okay. Now, let's look at both of Jack and Jill, just to summarize, because we just answered how many seconds does it take for each of them to run. Well, let's just look at Jill first. Her velocity was 9 meters per second, and she ran for a time of 500 seconds. So the distance that she ran, velocity times time, which is 9 times 500, is 4,500 meters. So she ran 4.5 kilometers. That's Jill. Jack, on the other hand, he's been running at 6. And the time that he's been running, he ran for 180 seconds to begin with, and then run for another 500 seconds. So he ran for 680 seconds. So the distance that he has run, velocity times time, is 6 at 680 seconds. So 6 times 680 is equal to 4,080 meters. So there's our little bit of a check. The distance that Jack ran plus the distance that Jill ran had better be the total distance. And it is. Jack in here says 4,080, and Jill is 4,580, and that does equal the 8,580 meters that we started with. Whoops. Thank you. Good. So this is like a little bit of a check. And then whose house are they closer to? Well, Jack. Jack hasn't run very far before they met. He only ran 4 kilometers where she ran 4.5. So the answer for the second question, closer to Jack's house.